So given a vector two vectors u equal to a b and vector v equal to c d, the dot product is basically a multiplication, so but it's not necessarily times. It's similar, but we call it a dot product. So v dot u dot v is equal to a, oops, it's actually going to be a number. It's no longer going to be a, let me change the microphone here. It's no longer going to be a vector. It's going to be a scalar, a single number. So a times c plus b times d. That'll be your dot product. Just multiply the I and j components. Okay. Let me see if I can come up with or find a formula page. We don't need a ton of them, but a few would be cool. Ah, can I drop that? No. Oh, 1 second. Sorry. just for now, use this, but I'm trying to get into PDF formats, but the computer I'm on doesn't have any software. Well, that's my lame version for now. But okay. Let's go ahead and look at it. The magnitude, and we already talked about this. Unit vector, right? You divide the vector by its own magnitude. If you add vectors, you only add the components, right? Here are the two different notations we used last time. Scalar means you multiply a number times your vector, and it only multiplies on each component. And here's both notations. Dot product is what we just did. You multiply the first component with the first, AC, plus B times D. And there's the IJ version, same stuff. This is another way to do the dot product. You do the magnitudes times cosine of theta. Cross we'll talk about later. I'm not sure if we'll do any of these, but we'll see. Well, the angle we will, but I don't know about projections. Okay. Let's look at the first few questions. So here, all they want us to do is multiply u times b. So go ahead and do that here, number 5. Find the dot product of u times b. So u times v is simply going to be 7 times -5 plus 2 times 3. So that is -35 plus 6. So that'll be -29, right? That's it. Nothing crazy. So the first few questions is simply just that, nothing else. Okay. Let me open the formulas again. Yeah, the notes also have a list of formulas you can use. That's also fine. But what we're going to use for the angle between is we're going to basically do the inverse of this formula. So here, let me show you. So in your notes right here, you can find the angle between two vectors by using the alternate form of the dot product. So if I do cosine inverse of both sides, then I'll have theta, right? So that basically creates a new formula. So theta is equal to the cosine inverse of the magnitude of u times the magnitude of v. So just use this. So question number 8. Find the angle between v equal to 30 and u equal to 0, -7. Okay. So I need to find the dot product and the magnitudes. The cosine is equal to theta is equal to cosine inverse of u dot v So let's do that over here. So u dot v is equal to 0, -7 dot 30, which will be 0. Let me show the work though.
Hey, Professor, sorry to interrupt.
Mm-hmm.
I actually did look back on the remind that you sent last, and it just said that it was 8.2. We had wrapped up 8.2, so we technically haven't done 8.3 yet.
I think A3 is similar to what we talked about. Let me see.
We did it last Wednesday.
Yeah, we did A3.
Oh, okay. I thought it was crazy. I didn't see it in the remind and I was like, oh God.
No, you're good. Maybe I just haven't sent it. I'll look into that. But yeah, I do remember talking about it. Okay, so now we need the magnitudes, right? Thanks for checking though, appreciate it. So this will be 3 squared plus 0 squared. That'll be 3. This will be 0 plus -7 squared, which will be 7. So this will be, well, I guess the bottom doesn't matter, does it? Should have, oh well, who cares? 0 over 3 times 7. It's cosine inverse of 0. When does that happen?
Pi over 2.
Yeah, pi over 2. So these two vectors have, so whenever the dot product, by the way, is a tip for you. Whenever the dot product is 0, then that means the angle will be 90 degrees, the angle between, or pi over 2. So these two vectors are perpendicular to each other. So whenever the dot product is 0, they are perpendicular, which means that the angle is pi over 2 or 90, same thing. Okay. So we'll do the same thing for 9, just multiply them together, find the magnitudes, and plug them into this formula here. Is there any questions about finding the angle between? Does that seem straightforward or no?
Very straightforward.
Okay. So let's move on to the next one. We just talked about this. Check it out. It's asking us, are these two vectors orthogonal? In other words, are they perpendicular? And in more other words, is the angle between them 90 degrees? So how would you check?
You can multiply them and see if they correspond.
Yeah,
Yeah.
you just what's it called? Let's do the dot product and see if it's 0. That's it. Okay. So is U dot V equal to 0? So 3 times -7 plus 15 times 5. What's 15 times 5?
45?
5 times 15.
My bad. I thought that was a 3 for a second.
Yeah, you're good. It looks like it. Be 30 more
15
than
times 5 is 35.
yeah. Yeah, 45 plus 30 more, yeah. 75, right?
Yes.
Okay, minus 21. It's not 0, is it? That's it. If it's 0, it is. If it's not, then it's not. Nothing else to say.
Yeah, and since it doesn't equal each other, it's also not parallel.
Yeah, since let me write it out in plain English here. Since u dot v is not equal to 0, then u and v are not orthogonal slash perpendicular. Same, just the same. That's just a synonym, right?
Yeah.
Okay, so that's pretty much it for 8.4. And you do a dot product. Can you use that alternate form to find an angle between? And can you determine if two vectors are perpendicular? Okay. Let's move on then. So 8.5 is when they start talking about the complex plane. So complex plane is basically they combine the real number system with the imaginary numbers. So those two together are all numbers, all types. So real numbers are almost every single type except the complex. Complex has everything, including the real numbers and the imaginary stuff. Okay, so that's the only difference. So the complex system has more subsets of different number systems. So think of the horizontal as your real axis and the vertical as your imaginary axis. Okay. So this right here, check it out. It says 1 plus 2i. So we have a real number of 1 and a complex part of 2. So that means you would go up 1 and then up 2 here. So this is my I component and my number component here. So this is real. Does that make sense? If it was 4i, you would go up 4. So this is the horizontal, vertical.
Makes sense.
So graph this guy. -6 is the real piece. So -6 is right there. 4 is the imaginary piece, is going to go up 4. So it's going to be right there. -6, 4. So here they wrote it as a point. And that's it. Any issues with graphing? Here they have a magnitude, so magnitude is still the same. The magnitude, remember we said magnitude is gonna be magnitude will be square root this piece plus this piece. Reduce this, that would be 4 times 13. Square root of 4 is 2. That's where this comes from. So it's very similar to the vector stuff. It's just you're treating this as your like ij. So this part is right here and here. So the magnitude of a plus bi, the official formula would be the square root of a squared plus b squared. So any questions on graphing or finding the length of this, or sorry, the magnitude?
No, that makes sense. I think that's pretty straightforward.
Okay.
Super simple sections.
Yeah, I'm hoping this last test is kind of chill. Okay. So this is basically just very simple algebra. Add the like terms. Oops. This would be 3 plus 4 the like terms plus I plus 8i. 3 plus 4, I plus 9i, or 8i, is 9. That's all we're doing. So the subtraction will be the same. Just be careful with your signs. Is there any question on adding or subtraction? Does it make sense? Do you want to see the subtraction? Or is it okay?
Makes sense.
Okay. We'll find the distance between. Excuse me. It's going to be the same distance formula. Let's look it up real quick. Here. No, that's the absolute value, which is basically very similar to the magnitude. Sorry, lost my train of thought there. Not there yet. Distance. Well, let's just use the same formula, that's fine. 90% sure it's the same thing. Okay. All right, so think of this as 2 points. So remember the distance formula. Think of this as -4, 1, -7, 4. So distance, we said a while back that it's gonna be equal to. Was it minus or plus? I wanna say it was minus. Yeah. Change them to points and we should be able to get it. To -7 minus -4. Y2 is 4 minus 1, okay. 7, -7 plus 4, that would be -3, so that'll be 9 plus 9. Which will be yeah. That'll be this. If we change them to normal points, we can still use the old school formulas, no big deal. That makes sense, or?
It makes sense. On the tests and stuff, do we have to show us factoring out the square root?
One more time?
On the tests, do we have to show factoring out the square root, or can we just leave it like at square root 18?
Oh, yeah, I wouldn't make a big deal about that. You get to there, it's pretty much good.
Okay, thank you.
All right, midpoint, you do the same deal. Changing the points. This is 4, 1. And 6, 7. We said that midpoints is equal to the sum divided by 2 of each component. So this will be 10. Well, let's show the word because 4 plus 6. 6 plus 7. That'll be 5. Hold up. Oops. That should be a 1. Be 8 over 2, 4. That's it. Any questions on this section? It's pretty much it.
It makes so much sense. Kind of feels like a review
Yeah, it kind of does.
using midpoint and distance.
Alrighty. I think that might be it. Let me see. Yeah, we're not gonna do. Let's see, or pretty much. Well, we got time, I guess. Don't think we're gonna do this guy. 8, 6. All right, 8.6. There's some good formulas in here. It starts off pretty slow. You can see. Right, 2 plus 2i. Remember that this is the imaginary part and the real part. So it should be here, right? That's pretty much it. See? That makes sense? Now, this part is a little harder, changing from a complex number to a trig form. We'll have probably to do that on the paper in a second. But basically, switch over. We'll leave this formula here. Space for a second. Here's the notes. Okay, I think it's in the 8.5 PowerPoint. That's cool. So given a complex number let's call it Z equal to A plus BI. The trig form, it's going to shorten up the formula here. Is Z equal to R times cosine of theta plus I sine of theta, where R is equal to the square root of A squared plus B squared. A is equal to R cosine and B is equal to R sine. And tangent theta is equal to B over A. All right, that should be more than enough to solve this question. So given a complex number 2 plus 2i. Change it to trig form. So we want to change it to this. So we need the r and we need the theta, and we'll be good. So first find r. Right? Okay, so then theta, we need this guy. Theta would be equal to tangent inverse of b over a. So that'll be tangent inverse of 2 over 2, which is 45 degrees, or pi over 4. Which you can kind of see when we graphed it. I was right in the middle. Okay, so just plug it in. So trig form is z equal to r cosine theta plus I sine theta, which will be 2 square root 2 times cosine of pi over 4 plus I sine pi over 4. That's how they got their solution. Here. That makes sense? You can see it's at the 45, right? Okay. So to change a complex number to trig form, you need the r and the theta. That's it. Get the r with this, which is basically kind of like the magnitude. R is the radius, which is similar to the length, right? Because it's in the center. Very similar to the vector magnitude. You'll do the same thing here. It's just that their angle will be something different here. I would say use degrees and then look at the circle to change it. Or change it yourself, that's fine. Number 6, they want us to go from this trig form and put it in standard complex. And all you got to do is evaluate it, that's it. So what is cosine of 60?
Is that 1/2?
Yeah, I think it's 1/2. That's number 6. Sine of 60.
The square root of 3/2.
Yeah, that's what it'll be. Now let's do it on paper. All you gotta do is evaluate and you're done. The 4 times cosine of 60 degrees plus I sine 60 degrees. That'll be 4 times 1/2 plus I times square root 3/2. Distribute your 4, and that'll be 4 times 1/2, that's 2. 4 times another half, that'll be 2. I don't know what, it doesn't matter where you put the I, but they seem to put it here. Doesn't matter. But you guys see the cancellation of the 2's, right? Any questions on 4 and 6 so far? Okay. Let me see the next couple here. I'm gonna find a specific formula. Just give me one moment. Here we go. Powers. This is the theorem we're gonna need for the next couple. Call it Demois theorem. Some French guy. So if z is equal to r cosine theta plus I sine theta, if this is a complex number, and n is a positive integer, then z to the n is equal to r cosine theta plus I sine theta to the n. So this will equal r to the n times cosine to the n theta plus I sine n theta. So it's pretty cool, right? So if you raise a complex number to the n, you can convert it to this trig form, and then it'll absorb the powers into the angles. Although the r will also receive it. So this can make it easier to evaluate high powers. So number 8. So 2 times cosine of 60 degrees plus I sine of 60 degrees. The whole thing to the 4th. So we said if the whole thing has an integer, you can just put it on this guy and then 4 times or n times the theta, so 4 times the theta. So this will become 2 to the 4th times cosine of 4 times 60 plus I sine of 4 times 60.
Sorry, I can't see your paper. Thank you.
So what's 4 times 60?
$240.
240, 2 to the 4th, that's what, 16, right? Cosine of 240. What is cosine of 240?
This is -half for me.
Yeah. This would be a -half plus sine of 240. It's gotta be this one, right? Is it positive or negative though?
It's negative.
Yeah. This is quadrant 3. Okay, so excuse me. Multiply your 16, that'll be -8 minus 8I root 3. Okay, any questions on number 8? Number 9, if you evaluate it, that's just going to be I to the 6th power. So, but That's fine. Let's do it. This simply becomes cosine 6 times pi over 2 plus I sine 6 times pi over 2. Right? Based on the formula up top. So this is cosine of 3 pi plus I sine of 3 pi. This is 0, giving me -1. Right, 0. Any questions on 9?
Pretty simple. Mine's just a little different. Mine uses the power of 18 and have to multiply that by pi over 6, but it's basically the same.
Yeah, it shouldn't be too different. Cool. I deleted the last questions after 10, so I wouldn't worry about those. If they're still there, you need to refresh your page. Okay, so on this guy, you want to change it to trig form first, and then take advantage of that formula. So in order to change it to trig form, we need to use this guy. So r is equal to the square root of 2 squared plus 2 squared, which is square root of 8, which is 2 square root 2. Theta is obviously going to be tangent inverse of 1, which is pi over 4. We did this earlier. This is supposed to be a 6. So, change this guy. This will become 2 root 2 times cosine theta plus I sine, oops, pi over 4 to the 6. So doing this to the 6 would be annoying, but doing this to the 6 is not a big deal. So this becomes 2 root 2 to the 6 times cosine 6 times pi over 4 plus I sine of 6 times pi over 4. 6 times pi over 4, what is that? 3 pi over 2, right?
Yeah, 3 pi over 2.
2 to the 6. What the hell is that? This will be 64. Root 2 to the 6, and be root 2 times root 2, which is 2. And again, 4. Again, 8. Yeah. Okay. Times cosine of 3 pi over 2 plus I sine of 3 pi over 2. All right. I don't know what the hell 8 times 64 is. It looks like calculator says 512. What is cosine of 3 pi over 2?
I got 0.
Yeah, it's gonna be 0. And this will be -1. So our result will be -512i. Any questions about the steps, or I guess the conversion from complex to trig form? And then using De Moivre's theorem to make the power simple.
I think for me personally, I just got to remember to do R.
What's that? To do what?
To do R, the 2 squared plus 2 squared. Because I tried to do it before, but I got the wrong answer because I didn't do it properly.
Oh, I got you.
Yeah, just I skipped that step on accident.
You just ignored the R completely.
Yeah.
No, it's all right. It's not a very pretty R anyway. Okay. Well, that's pretty much it, guys. That's the last section in the whole class. So I guess Monday, let me see here.